Okay, how do we write down a polynomial given its roots? Well, we know that if we have a root, we have a factor. So if we want to write down, for example, a polynomial with roots 5, -3, 0, and 4, well, having a root of 5 means we have a factor x minus 5. A root of -3 means we have a factor x minus -3, which we usually write as just x plus 3. If we have a root of 0, that means we have a factor of x minus 0, which we'll write as just x. If we have a root of 4, well, then we have a factor of x minus 4. So, well, the easiest way to write down a polynomial with all those factors is to just multiply them all together. I'm going to write my factor of x at the beginning because it looks nicer that way. And there we go. Here's a polynomial that has all 4 of these roots. Is that the only way that we can do it? Well, we can't add any extra factors without adding more roots, unless we have a factor that we're sure is never 0. Now, if we have a number that doesn't equal 0, we can be sure that that's never 0. So we can add in numeric factors. And it turns out that any numeric factor we add into something like this is going to end up, well, we'll multiply x, 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 x when we're getting our leading term. Any numeric factor that we put in is going to end up as our leading coefficient. So if we're told that we want a certain leading coefficient, we'll just add that as an extra factor. And we know that that's not going to change the roots because, for example, 7 is never 0. So here we want to write a polynomial with the roots. So here we want to write a polynomial with roots -3, 4, and square root of 5. Square root of 5. Well, okay, that's a perfectly good number. If we want to have a root of -3, well, that gives us a factor of x minus -3, which we'll write as x plus 3. If we want to have a root of 4, that gives us a factor of x minus 4. And if we want to have a root of the square root of 5, well, that gives us a factor x minus the square root of 5. Notice, we never saw a factor like this before, but that's certainly a polynomial. There's no reason we couldn't have it as a factor. So our factors are going to be x plus 3, x minus 4, and x minus the square root of 5. And then this leading coefficient, we just drop it in front. So we throw in all of those factors, we put the leading coefficient in front, and we're done. We can leave this in factored form, unless we have some reason to want it in another form. In math class, our reason to want it in another form is usually because someone told us to, or because we're going to do some next step. So in this example, we want to give our polynomial in standard form. So we want roots -4, square root of 3, and negative square root of 3, and a leading coefficient of 1. Well, root -4, that'll give us the factor x minus -4, which is x plus 4. Root 3, that'll give us the factor x minus root 3. Root negative square root 3, that gives us the factor x minus negative square root 3, which is x plus square root 3. So our polynomial, we have x plus 4, x minus root 3, x plus root 3, and leading coefficient 1. Now this problem asks us to give our answer in standard form, so we've got to multiply this out. Remembering as I do my special forms, I notice that this is going to be much easier if I multiply these first. So first I'm going to take x minus root 3 times x plus root 3, which gives me x squared minus root 3 squared, which is x squared minus 3. And then I'm going to take x plus 4 times x squared minus 3. X times x squared is x to the third. And then I've got x times -3, 4 times x squared, 4 times -3. And then, well, multiplying that by 1 doesn't do anything. Strictly speaking, I'm not required to write these terms in descending order in my answer, but it's an awful lot nicer if I do. I'll have x to the third plus 4x squared minus 3x minus 12. And again, the reason that I knew I had to multiply that out is because the problem says standard form, and standard form means multiplied out.